Ooh, I forgot to put the projector on. Bugger. Shit. No, just you guys. Alright. Alright, shush. I'm going live now. Right, welcome to today's stream. We're doing sheet 7 and we're going to start off with a nice little arithmetic question here. So have a go at that. I'm going to give you, I think it's definitely doable in 2 minutes. So see if you can do that. Okay, so nice easy question. My class manager all finished that well within the time. So let's get on with the answer. So we know that the nth term is equal to a1, the first term, plus n minus 1 lots of d. So therefore we have got a1 equal to 11 and we got d is equal to 4. And we know our nth term is 643. So 643 will equal the first term 11 plus n minus 1 times 4. So what we get is 600 and for 32, if we take 11 off both sides, equals 4n minus 4. Add 4 to both sides, we get 636 is equal to 4n. Divide both sides by 4, and what do we get? We get 100 and, is that 59? 159 for our final answer. So let's go and look at the next question. So to determine the range of values for A for which the cubic has no stationary points. I'm really not sure how long this will take you, so I'll set the timer at 5 minutes maximum. You should easily be able to do it under that. I think it might even finish before that. Right, just giving you another 30 seconds before we stop that, because most of my class are getting to an answer at this stage. Right, let's have a look at this question. So we want to determine range of values of A for which the cubic x cubed has no stationary point. So the first thing we need to do is differentiate. So we'll find dy by dx, and we get 3x squared plus 2ax plus 4. And we want to find when this has no stationary points. So if we have stationary points, then this must be equal to 0. For it not to have stationary points, then there must be no solutions. And for this to have no solutions, then b squared minus 4ac must not be equal, must be less than 0, sorry. Must be less than 0. Okay, because we'll end up with a negative square root and we can't solve that. So b squared is going to be 2a all squared minus 4 times 3 times 4. So we get 4a squared minus 12 times 4 is 48 is less than 0. So we're going to get a squared is less than 48 divided by 4 is 12. So therefore we know that a is going to be less than the square root of 12, which is going to be 2 root 3. Square root of 12, we should know, is 4 times 3. Bring the 4 out, we get 2. But that's not all of it. You think about it, your a squared, okay, you're squaring something and you want it to be less than 12. There's going to be, sorry, I just created a rubber by mistake. There we go, get my graph back. So, get my a squared. So we're less than 12 here. There's 2 root 3 is one critical value, and also minus 2 root 3 is the other critical value. So it's going to be between those two values. And that's our answer. So, next question. Right, this question is taken from a previous question on the previous sheet. So it says modify the equation in sheet 5, question 4 to accommodate the 11.5 hour tide. This is the equation here, x equals 11 plus 7 sine pi by t over 6. So that's the equation we've got to modify in this question. I'm just going to drop that down to 2 minutes to do this question, because it's one you either can or can't do, I think. Right. You may not have finished that because it depends on how good you know your transformation of graphs. Let's just have a look at the graphs involved in this. So this is our original graph, the red one. Okay, that's 11 plus sine pi by 6. And we can see that, okay, its wavelength is 12 hours long. So it goes from here to here, goes through a whole cycle of tides in 12 hours. And what we want to do is change that so it's 11.5 hours. So it's going to finish about here. So this is the graph, and you can see the equation I came up with. And basically what we're doing is we're doing a stretch. We're going from 12 to 11.5. We're doing a stretch, scale factor 11.5 over 12. And when we do that on the graph, you do it inside, and we actually don't times by 11.5 over 12, we times by 12 over 11.5. So let's just get our work back up on here. So we want to do a stretch, scale factor equal to 11.5 over 12, because we're going to make the wavelength that many times shorter. Now, what you should realise, if you want to stretch scale factor of A, if you want to, or 1 over A, then you've got to times by A inside the function. You should know that. That's one of the facts you've got to know. So therefore, if we want to stretch this for scale factor A, we've got to times this by 1 over A. So we want to stretch for scale factor 11.5 over 12. We need to times by 12 over 11.5. So x is going to equal 11 plus 7 sine pi by t over 6 times 12 over 11.5. We could simplify that a bit if we wanted. The 6 will cancel out to give me 2 pi t, and we got that over 11.5, although that's a bit nasty. I'd rather have it as 4 over 23 would be probably nicer. So let's just rub that out and put whole numbers on the bottom. And that's probably a neater version of our formula. Now we want to find the speed at which the water level is rising 3 hours after its mean depth of 11 meters. So let's just quickly go back to our graph. So after its mean depth of 11 meters, we want to find out the speed at which it's rising or falling 3 hours later. Okay, over here. So let's just do that. So what we need to do is we need to find dx by dt. The 11 will just disappear, so we're just going to get all of this here. Okay, we're going to have to times by 4 pi over 23 out by 7. So we're going to get 7 times 4 is 28 pi over 23 as a multiplier outside. The sine will go to cos. And we've got 4 pi t over 23 inside. And all we do is we just got to put in when t equals 3. So put t equals 3 into that, shove it all into your calculator, and you'll get dx by dt is equal to 3.82 meters per hour. Next question. Find the equation of tangent to y equals 3 sine 4x when x is pi by 6. I'll give you 2 minutes to see how well you can get on with that. We'll just give you an extra minute because my class seemed to need it. Okay, so here we go. We're going to find the equation of tangent y equals 3 sine 4x when x is equal to pi by 6. So the first thing we need to do to find the equation of tangent is we need to differentiate. So we're going to find dy by dx, and we're going to differentiate the sine to get cos. When we do the chain rule, the 4 will come out, so we get 4 times 3 gives us 12 cos of 4x. And we want to substitute x is pi by 6 into that. So therefore, we get dy by dx is equal to 12 cos of 2/3. Sorry, rub that out. X is pi over 6, so I'm going to get 2/3. We're going to do pi over 6 times 4, 2/3 pi. Okay. Now, that's going to give me equal to -1/2. How do I know that? So 2/3 pi, there's half pi, 2/3 pi is about a 1/6 pi past here. And we know that at a 1/3 pi that way, we're going to be at 0.5 on here. So this is going to be minus 0.5. You can always shove it into your calculator as well. So we're going to get 12 times minus 0.5. And that gives us -6. If we put in 6 pi into this expression, then we're going to get y is equal to 3 times 3 root 2. Okay, you can just shove that into your calculator and get that value out. So you put pi by 6 in for the x, times by 4, do sine, times by 3. Make sure you're in radians. And so therefore, the equation of the tangent is y minus the y value, root 3 over 2, is equal to the gradient minus 6 times x minus the x value, which is pi by 6. And that is an answer. We could try simplifying this. There's not a lot we can do to make it simpler. We can multiply out the brackets. It doesn't really simplify anything. We can put it in y equals mx plus c form. So there's your m, here's your c coming up, and we're going to get plus pi by 6 here. And I've forgotten to times my pi by 6, so let's just get rid of that to get just pi. So minus 6 times x is minus 6x, minus 6 times minus pi by 6 is pi, add on the root 3 root 3 over 2. So next question. Okay, we're going to derive, okay, the expressions for sec and cosec. Just go through them, make sure you know them, and then you're going to use the chain rule to try and differentiate sec and to differentiate cosec. I'll give you 3 minutes to start with on that question. Right, if you know what you're doing, you should have been able to get that out by now. If you couldn't, then it probably means you need to practice your chain rule differentiation a little bit more. So we know that sec equals 1 over cosec, cos. Cosec x is equal to 1 over sine x. Now we're going to use the chain rule to show that d dx of sec x, well, that's just going to be equal to d dx of 1 over cos x, or cos x to the minus 1. But it's not inverse cos, it's cos of x all to the minus 1. Now, if we're going to do chain rule, I should do this one fully, showing you the full method of chain rule, and then the next one we'll try and do it in our heads to see how fast we can do it. So if you have u equals to cos x, and then we're just going to let y equal u to the minus 1, because u is cos x. So du by dx will equal cos goes to minus sine x, and dy by du is going to give us minus u to the minus 2. So therefore dy by dx will equal minus sine x times minus u to the minus 2. Well, the u bit is cos. So we get cos x to the minus 2. So that is equal to, we've got minus sine x times minus cos x, so that's going to give us a plus. So let's just get rid of that for now. Let's rub that out. So we're just going to get sine x over cos squared x. Well, let's just write cos x as cos x times cos x. And effectively, you've got sine x over cos x times 1 over cos x. Well, that just equals tan x times sec x. And we usually write it sec x tan x. Now, let's just move across, just give ourselves a bit more space. So we're going to do the same for cosec. So I'm not going to do all this. I'm going to try and do it in our heads. So we're going to do d dx of cosec x. And that's equal to d dx of 1 over sine x, which is sine x all to the power of minus 1. So the sine, the inside bit, will differentiate. I'm just going to write this out here. So we've got sine x to the minus 1. Let's just, write it properly. So differentiate the sine x, we get cos x. Now we differentiate the power, we take we times by the power, so it's minus 1, times by the power, it's minus 2. So we're going to get sine x all to the minus 2. So that gives us minus cos x over sine x times by 1 over sine x. Is another way of looking at it. What I'm doing here is effectively is cos x over sine squared x, but I'll just split this up into times 1 over sine x. So it's easier to see that this is just cot x, and this is just cosec x. Okay, so you can see how we go about doing the chain rule differentiation in our heads, and you should be able to do that by this stage of the course. We're doing this in the end of November. Right, next question. Let's just scroll across if I can get on my screen and get the next question up. Here we go, question 6. Nice, quick, easy one. You should be able to do this really quickly at this stage. Using a suitable compound angle for final expression for cos 2a. Using an answer to this, or otherwise, you can show that cos 2a equals this, or cos 2a equals 1 minus sine squared a. I'm only going to give you, let's see if you can knock that off in 1 minute. You should be able to do that by now. Right, let's see if I can do it in 1 minute with explanation. So let's set the timer. So we know that cos 2a is effectively equal to cos a plus a. And cos a plus a is equal to cos a minus sine a. So that gives us cos squared a minus sine squared a. So that was our answer to A. And for part B, if we write cos squared is equal to 1 minus sine squared, so we get 1 minus sine squared a minus sine squared a, and that will equal 1 minus 2 sine squared a. And we also, if we write sine squared is equal to 1 minus cos squared, we get cos squared a minus 1 minus cos squared a. Minus and minus gives me a plus, so that will give me 2 cos squared a minus 1 with 6 seconds to spare. So the three formulas you should know are cos squared a minus sine squared a equals cos 2a. 1 minus 2 sine squared a is also equal to cos 2a, and 2 cos squared a minus 1. It's important you know these three formulae all off by heart. Next question, and to finish off, we'll give you, let's just give you about 3 minutes to play with this one and see how you get on. Right, okay, so we want to show that this polynomial x cubed minus 3x squared minus 2x minus 5 equals 0 has a root in the interval 3 to 4. So if we let, let's just get the right colour here, so if we let f of x equal x cubed minus 3x squared minus 2x minus 5. Then f of 3, put 3 into this, 3 cubed minus 3 squared minus 2 times 3 minus 5, and we get minus 11. And if we do f of 4 and do 4 cubed minus 3 times 4 squared minus 2 times 4 minus 5, we get 3. So as there is a sign chain, is a sign change, there must be a root between 3 and 4 as f of x is continuous. We know all cubics are continuous functions. Okay, so there's no discontinuity, there's no asymptote that we've got to get past in this range because it's a continuous function. So if we know that xn plus 1 is equal to 3x squared xn plus 2xn plus 5 all over x squared n. So this is just a rearrangement of this formula where if you let x equals this, okay, we can, if you rearrange this so you get x as a subject by taking everything to the other side and dividing by x squared, you can create an iterative formula. And there are ways on different videos I can show you why that works, but it just does in this case for today. What we're going to do is grab a calculator and show how we might do this. Let's see if I can just, is there a way of making that bigger? Well, let's just do that on that size calculator. So what we're going to do is we're going to do, open brackets, 3 times, let's start off with x is 3. So do 3, what I'm going to do is I'm going to do 3 and put equals, x is 3. And then what I'm going to do is I'm going to do 3 times the answer squared. I just realised I need to put some brackets in. Put a bracket in there, go to the end, 3 times the answer squared, plus 2 times the answer, plus 5. And then I'm going to divide all of that by the answer squared and make sure I put brackets around that. So square it before I divide it and press equals. And I get the decimal, I get 4.22 as my first value. So starting with x is 3. So if I've got x equals 3, then x1 equals 3, x2 will equal 4.22. And just grab my calculator back again. And we press equals, we get 3.75, press equals again, we get 3.8, 3.84, 3.85, 3.8454, and 3.855. And we can see that to 3 decimal places, we're getting to 3.855. Now you need to show a few more values than that. So x3 is equal to 3.75 it was. X4 was equal to 3.878 even. And x5 is 3.84. And so on and so on and so on. And we found that x tends to 3.855 to 4SF. And that is our final answer there. So that's the end of this sheet. We'll be doing sheet 8 tomorrow, Friday. It's the only Friday I'm going to do in this series. The rest will all be Monday to Thursday at 5 o'clock. So the next sheet we'll be doing tomorrow at 5 p.m.